And now we're going to start section P-2, and this section covers exponents and radicals. Again, this is stuff you should remember well from Algebra 2 and even Algebra 1. Exponential notation: if a is a real number and n is some positive integer, then a to the nth power is a times a times a times a, n times whatever n is, where n is the exponent, a is the base. The expression a to the n here is read as a to the nth power. Again, if you have x to the third, that is just x times x times x 3 times. The properties of exponents. First property: if the bases are the same and you're multiplying, you add the exponents. Like if you have 3 squared times 3 to the 4th, the bases are the same and you're multiplying, so the base stays 3, and the new exponent is 2 plus 4, or 6. And 3 to the 6th is 729. If you are dividing like bases, we have a fraction, both bases are a, now the exponents again are m and n, but we subtract. The base stays the same, base a, and the exponent is numerator exponent minus denominator exponent, m minus n. Like x to the 7th divided by x to the 4th, the base is still x, and the new exponent is 7 minus 4, or third power. Negative exponents. We have a to some number and it's a negative number. Remember, a negative exponent is just a misplaced base. So we move this a to the nth power down to the denominator, and now that exponent becomes positive. A to the negative n is 1 over a to the n, positive n. And if we want to, we can pull that exponent out. We can parenthesize off the whole fraction and put that n up top. 1 over a to the nth, 1 over a all to the nth power. Like if you see a y to the negative 4, just move that y to the 4th down to the denominator and make it positive. You know, there is a 1 here in front of that y to the negative 4th. The 1 stays up top, the y to the 4th goes down to the bottom to become positive, and then it's 1 over y all to the 4th power. A to the 0 is equal to 1, as long as a does not equal 0. Anything raised to the exponent of 0 is 1. Here we have a quantity in parentheses, x squared plus 1. Doesn't matter what this is in here, it's all to the 0 power. No matter what, that's equal to 1. Now here we have a quantity raised to an exponent, a times b, all raised to the nth power. Think about it as distributing. I'm going to distribute this exponent first to the first term, a to the m, and then to the second term, b to the m, a to the m times b to the m. Like here we have 5x in parentheses to the third power. That 5 gets its own exponent of 3. 5 to the third times x to the third. And then 5 to the third is 125. Now here's the scenario where you actually multiply the exponents. A to the m raised all of that to the nth power. So this would be a to the m times a to the m times a to the m, n times. But we can simplify that, just keep the base a, multiply the m times n. Like y to the third, all to the negative 4th power. We just multiply those exponents, y to the negative 12th, and then move that y to the negative 12th down to the denominator and make it positive, y to the positive 12th. If you see a fraction all raised to a base, and that numerator is not a 1, you can distribute that outer exponent m first to the numerator, a to the mth, and then to the denominator, b to the mth power. Like here in the example, 2 over x all to the third, that becomes 2 to the third over x to the third, or 8 over x to the third. Now a little bit with absolute values. If we have the absolute value of a squared, that's equivalent to the absolute value of just a, and then you square that quantity, and that's the same thing as a squared. And you know, the reason this works is, remember, no matter what, if you square a negative, it's going to become positive. You know, in the first example here, it's negative 2 quantity squared, so negative times negative 2 is 4. Here we have absolute value of negative 2, that quantity squared. Well, the absolute value of negative 2 is 2, and then 2 squared is 4. And that's just the same as positive 2 squared, or 4. So here in example 1, we're going to evaluate some exponential expressions. Watch a and b, look at the difference between them. The only thing that's missing here, in a we have a set of parentheses around the negative 5. Here there are no parentheses. That is a huge difference. Here it is quantity negative 5 squared. So that is negative 5 times negative 5. Negative times negative is positive. 5 times 5 is 25. Now here in the second one, this is negative 5 squared. Negative 5 squared. So now we have a negative, and then we're going to do r squared. 5 times 5. Well, the 5 times 5 again is 25, but now we have the negative sign along with it. So there is a big difference, in the answers between those problems with the parentheses. Letter C, 2 times 2 to the 4th. Does this first 2 have an exponent? Sure it does. Well, it's implied. We don't write it all the time, but it's 2 to the 1st times 2 to the 4th. So we can use our property. The bases are the same. They're both 2. And the exponents. Now we add them. 1 plus 4 is 5. And 2 to the 5th power is 32. The last one, we have a rational expression, 4 to the 4th over 4 to the 6th. So the bases, again, are equal. Our answer is going to have a base of 4. And our exponent is numerator exponent minus denominator exponent. 4 minus 6, or negative 2. 4 to the negative 2 power. Well, let's get rid of that negative exponent. This is 1 times 4 to the negative 2, so the 1 stays as the numerator. The 4 to the negative 2 goes downstairs to the denominator and becomes 4 squared, which is the same thing as 1/16. Good stuff. Example 2, evaluate algebraic expressions. Evaluate each expression when x is equal to 3. So we have 5 times x to the negative 2. Before we even plug in 3 for x, let's get rid of that negative exponent. Those are kind of distracting. So now is it going to be 5x squared under a 1, or what happens? Remember, this 5 does have its own exponent. That is 5 to the 1st power. It's a positive 1st power. So 5 to the 1st, that stays up top. The x is the only thing with the negative 2 exponent. So that x to the negative 2 moves down and becomes x squared. And just for completeness sake, let's say this was 5x quantity to the negative 2. If there were parentheses around that 5x and it was all to the negative 2, then that would be 1 over 5x quantity squared. But back to the problem they gave us, we now have that as 5 over x squared. Now we can plug in the x is 3, 5 over 3 squared. And we know that 3 squared is 9, 5/9. Let's see, here we have 1/3 times the quantity, negative x to the 3rd. Well, let's plug in our x right away. 1/3, and then we have a negative, and then an x, and our x is 3 to the 3rd power. By order of operations, we should do the exponent first. So this is negative 3 to the 3rd. That's negative 3 times negative 3 times negative 3. Let's figure out the sign. Here's positive times negative is negative, and that negative times another negative is positive, and that positive times another negative is negative. Our final answer will be negative. Let's see here. 1/3 times 3 is 1, times 3 is 3, times 3 is 9. 9. Negative 9. Alrighty. Example 3, properties of exponents. Use the properties to simplify each expression. Usually when they say simplify, it's bad manners to leave negative exponents in these types of problems. So let's see what we got here in letter A. Good, I can move these down, give myself a little more room. They're asking us to multiply negative 3ab to the 4th times 4ab to the negative 3rd. I like to look at these piece by piece. Let's first look at the numbers. Negative 3 times 4 is negative 12. Next is a to the 1st times a to the 1st. Well, that's a squared. Add the exponents when you multiply like bases. Then we have b to the 4th times b to the negative 3rd. So we are going to have a b, and our new exponent is 4 plus negative 3, or 1st power, which we don't even really have to write on there. So we have negative 12, a squared, b to the 1st, and that's as simple as we're going to make it. Let's see what we got here. So we have a quantity to the 3rd power, 2xy squared to the 3rd. There's a couple ways to think about this. We could write that out and multiply it 3 times. 2xy squared times 2x y squared times 2x y squared. So I just, wrote that term out 3 times. And we could multiply this way. 2 times 2 times 2 is 8. X times x times x is x to the third. Y squared times y squared times y squared is y to the sixth. That's one way to look at it. A different way, instead of writing it out and multiplying, would be to distribute that outer exponent. So we would distribute that third power. That would be 2 to the third. Distribute it also to the x. There's already a 1 there, so we multiply. 1 times 3 is 3. And then y squared to the third, again, multiply the exponents, y to the sixth. That's a sixth. 2 to the third, again, is 8. And then we have our x to the third, y to the sixth, just like we found the other way. When I look at letter C, before I even start, I like to scan across the problem. And what really jumps out at me is that power 0. We have something to the 0 power. And what that is to the 0 power is all this in the parentheses. And it doesn't matter what this is. No matter what that is, it's all to the 0 power, and anything to the 0 power is 1. So we have 3a times, that would be a 1. And of course, 3a times 1, or anything times 1 is itself. Here it's just 3a. Letter D. We have a rational expression raised to a second power. So let's distribute that second power through the numerator first. Across the numerator, we're going to have a 5 to the second power. And then we have our term x. We distribute to that x to the third. Multiply the 3 times the 2. That is now x to the sixth. And don't forget the denominator. Distribute that also down there. So that'd be y squared. And of course, 5 squared is 25. 25 x to the sixth y squared. Example 4. Rewrite with positive exponents. Again, leaving negative exponents in an expression is bad mathematical manners. So we want to get rid of them whenever we can. Here is x to the negative 1. Remember, there is a implied 1 there, 1x to the negative 1. And that 1 also has its own exponent, so it's going to stay up top in the numerator. X to the negative 1 goes downstairs and becomes x to the positive 1, which you could just write as 1 over x. Now here's a little different scenario. We have a negative exponent, but it's already in the denominator. And a way to think about this is, we have our divider line in our rational expression. No matter what, if it's numerator or denominator, when that negative exponent jumps across that line, it switches the sign of its exponent. So if it's a negative exponent in the numerator and you move it down, it becomes a positive exponent. Here it is already a negative exponent in the denominator, so we're going to move it up across that divider line where it will switch signs. So that x to the negative 2 moves up top and becomes x to the positive 2. Oh, and that looks like a 3, x to the positive 2. The 3 in the denominator already had its own exponent, so that stays down there. That's 3 to the first. All right, letter C. A little more complicated here. We have numbers and a couple different variables. So let's see here. The 12 over 4, if you look at that as a fraction, we can reduce it. We could pull out the common factor of a 4. So we could reduce that down to a 3 and a 1. Let's see here. A to the third, that's already positive, so that's going to stay up top. This b to the negative fourth, it's negative in the numerator, so I'm going to move that down to the denominator. So this b to the negative 4 in the numerator becomes b to the positive 4 in the denominator. So now let's move down to the denominator. We've already taken care of the 4. Down here in the denominator, we have a to the negative 2. I'm going to move that up top, where it becomes a to the positive 2, a squared. Down here in the denominator is a b to the first, and it's already positive, so I'm going to leave it there. And now we can simplify a little bit more. In the numerator, we have a 3. A to the third times a squared is a to the fifth. The 1 we don't have to write. B to the fourth times b to the first is b to the fifth. Okay, in this last one, we have a rational expression all to a negative exponent. Now I'll show you how to do it the long way, and then there is kind of a shortcut you can do. the way we've done these problems before, we'll distribute that exponent. So that's going to become 3 to the negative 2 power. And then we're going to have an x base, and this exponent will be 2 times negative 2 is negative 4. Distribute also to the denominator, and then it is y to the negative 2. Now, if we look at this, everything has a negative exponent, so everything is going to jump across the divider line. In the numerator, 3 to the negative 2 moves down and becomes 3 squared, which we can rewrite as 9. X to the negative 4 in the numerator becomes x to the positive 4 in the denominator. And our old denominator, y to the negative 2, moves up and becomes y to the positive 2 power. Now let's compare that to the original problem. What we could have done, sort of like the little shortcut trick to this is, if we take a fraction to a negative exponent, if we flip that fraction over, here, just looking in the parentheses, I'm going to flip what is there over. Y is the numerator, 3x squared is the denominator. If you flip this fraction, the exponent switches signs. So instead of negative 2, this is now positive 2. And if we distributed this, y to the second power in the numerator, that's what we have right here. And into the denominator, 3 squared would be this 9, and x squared squared would be our x to the 4th. So you can do it the long way, take a couple extra steps, or if you remember, if you have a fraction to a negative exponent, flip the fraction, flip the negative to a positive, and you're done. I think this is the last thing we're going to cover in this video, and that's scientific notation. This is something, again, you should remember from earlier classes. The first one, write each number in scientific notation. So remember, we want to move that decimal so we have a number, the decimal, and then the rest of the number after it. Here it looks like I want to move the decimal 1, 2, 3, 4, 5 spaces. 5 spaces. So my number is going to be 7.82. 7.82 times 10 to some power. And I know that power is going to be a 5, but is it a positive or a negative 5? I always remember, decimal numbers, these very, very small decimal numbers, are always negative exponents. For part B, we have to move that the decimal 1, 2, 3, 4, 5, 6, 7, 8 spaces. And then our number is 8.361 times 10 to what power? Well, we had to move that decimal 8 places. And because this number is very big, 836,100,000, this is going to be a positive exponent. 10 to the 8th power is a very big number. And in example 6, we're going to reverse the process. Write each number as a decimal. So here it's negative 9.36. I'm going to do negative 9.36. And because this exponent is negative, I know I'm going to have a very, very, very small decimal. So I'm going to move this negative over here. And I'm just going to add in a bunch of zeros. And let's see how many spots I got to move that decimal. Had to move it 6. Negative, you move the decimal to the left. 1, 2, 3, 4, 5, 6. There we go. So it's negative 0.0000936. And I'll move back up here for part B. 1.345 times 10 squared. When this is a good one, it's a positive power, so we're going to move our decimal to the right, and we only got to move it 2 spots. We had 1.345. So I'm just going to move that decimal 2 spots. 1, 2, 134.5. And then, this is just simple manipulating those around. We are going to do one here where we evaluate this. And here's where, those properties of exponents are going to help us out quite a bit. We could do this on the calculator. Some calculators might not be able to handle that many decimal places. So let's start out by changing everything to exponential notation. Here we have 2,400,000, or 2.4 times 10 to some power. And that power, our decimal, we want it to be right here. We're going to move that decimal 3, 6, 9 spots. 10 to the 9th power. And we're going to multiply that by this number in scientific notation. I'm going to move the decimal 1, 2, 3, 4, 5, 6 spots. So 4.5 times 10 to the negative 6 power. And in the denominator, I got to move this decimal 1, 2, 3, 4, 5 spots. So that's 3.0 times 10 to the negative 5th power. And then 1500, move that decimal over 1, 2, 3 spots. 1.5 times 10 to the 3rd power. So here, we can just do the numerator and denominator separately. I'm just going to multiply these numbers. 2.4 times 4.5 is 10.8 times 10 to what power? Well, this is 10 to the 9th. This is 10 to the negative 6, so we keep the base 10 and add the exponents. 9 plus negative 6 is 3rd power. Denominator. 3.0 times 1.5 is 4.5 times 10 to the negative 5th times 10 to the 3rd is 10 to the negative 2nd. And now here, let's see, we can just divide. 10.8 divided by 4.5, if I just divide these out, I get 2.4. Times 10. Here we have base 10s, our exponent, or it's a rational expression, so we subtract our exponents. 3 minus negative 2, 3 minus negative 2 is 5. 2.4 times 10 to the 5th power. And if we want to rewrite it without exponential notation, we have our 2.4, and we're going to need a bunch of zeros after it. And we would move that decimal 5 spots. 1, 2, 3, 4, 5. So that is, what, 240,000. Practice problems, team Huddle. In the first few, evaluate the expression using the properties of exponents. The second couple problems there, 33A and B, are simplify it as much as you can. Get rid of negative exponents if there are any. And the last couple are just rewrite as scientific numbers. So pause the video, try the problems, start her back up, and see if you got them right. So the first one here, evaluate. We have 3 squared times 3, and remember that's 3 to the 1st power. So we're multiplying like bases, keep the same base 3, add the exponents 3 to the 3rd, and that is 27. In 12a, 5 to the 5th over 5 squared, we are dividing, and we're dividing like bases, so we keep the base 5 and subtract the exponents top to bottom. 5 minus 2 is 3. 5 to the 3rd is 125. Aha, 17 might be a little tricky. 2 to the negative 1 plus 3 to the negative 1. Well, negative exponents, let's get rid of them. 2 to the negative 1, we move the 2 to the negative 1 downstairs and make it positive, so that's 2 to the 1st, or just 2, 1/2, plus 3 to the negative 1. That becomes 1 over 3 to the 1st power. 1/2 plus 1/3. So we are going to add fractions. We need a common denominator. So let's multiply the 2 we have. Sometimes that won't be the least common denominator, but it will be a common denominator. 2 times 3 is 6. And then multiply upwards. First this way. 3 times 1 is 3. This is a plus sign, so it's plus. 2 times 1 is 2. Our numerator 3 plus 2 is 5 over denominator 6. 5/6. Oops. So now we simplify if we can. 6y squared times 2y to the 0, quantity squared. Well, I know, again, the first thing that jumps out at me is that 0 power. 2 times y to the 0, well, y to the 0 is what? Y to the 0 is 1. So here in the parentheses is 2 times 1, or 2, and that quantity is squared. Okay, 2 squared is 4, and we multiply that 4 by the 6 we already have. 6 times 4 is 24, and we still have our y squared. All right, letter B. We have 3x to the 5th over x to the 3rd. There's no number down here in front of the x to the 3rd besides that 1, so the 3 is going to stay put. We are dividing like bases, so we keep the same base x, subtract the exponents. 5 minus 3 is 2. 3x squared. Okay, last couple. Write each number in scientific notation. Again, I want to get my decimal in here between the 1 and the 0, so I have to move it 1, 2, 3, 4 spots. So I'm going to have 1.02504 times 10 to the fourth power. 10 to the fourth power. This number here, the first thing that jumps out at me is it's a very small number, decimal point 000, and then we have our number. So that tells me my exponent is going to be negative. And I want to move that decimal 1, 2, 3, 4 spots. Negative 1.25 times 10 to that negative fourth power. And I think that's it for the practice. The assignment for this section, Chapter P, Section 2, First Day. We will finish this section tomorrow. Homework comes from page 21, these problems. Remember, odd answers are in the back of the book. Even answers are not.